Okay, good morning. Today we continue discussion over natural language processing. The overarching goals of today's class is getting familiar with the data preparation part, because actually the biggest differences between natural language processing and simple machine learning project in either standard that you use, more specifically CRISP-DM, you have an extra step of data preparation, or your data preparation is more complicated because you should convert your textual document into numerical format. But the rest is pretty similar. You can do feature selection, principal component analysis, apply machine learning either for classification, prediction, any supervised or unsupervised learning. So also, we use some concepts and getting familiar with more NLP concepts, and also we learn how to install a package into a Spark environment. Having said that, for today's class, please go to your model, download LSA Jupyter Notebook and also sample text CSV. Then go to Databricks, run a cluster, and also upload these files into your Databricks account. I give you 5 or 6 minutes to do that. Same for the people in the class. So people in the class, you also can enjoy chocolate. So for you, just join class. So they go to the model week 12 and upload the documents into the Databricks account. So you guys have 5-6 minutes to do that. So take more. You don't have to take one. Take as much as you like. Just put it there. So again, for the people over Zoom, so my distance with your friends is more than 6 feet, and also you need to hear me. It's the reason I don't have mask. But whenever I go to your friend's desk, I put on my mask. Yeah, go over week 12, upload the documents into your Databricks account. Oh, not this one. This is the old one. So this. Okay. Today, we studied latent semantic analysis. Basically, we want to get some inference from the concepts or the meanings that under hood of our document. We want to see what it's about. So let's just review some terms that we had in the previous session. Like natural language processing refers to a family of techniques used to derive meaning from textual data. A document refers to some collection of words and represent instances or row of our data set. Basically, each row is a document. Could be one sentence, could be several sentences. A body is basically our data set. Dictionary is all of the words that appear at least one document in our body. Topic, collection of words that co-occur. Let me just read this one. The word latent means hidden. In this context, we are referring to features that are hidden in the data, that they are hidden refers to the fact that they cannot be directly measured. These latent features are essential to the data, but are not original features of data set. So there is some meaning behind of some text. For example, you might remember in the previous antics class, we have some sentences or document has a positive, negative sentiment. Some of them might be, you might work with the tweets data that refers to election, animals, or any regular news. So all of them are basically under latent semantic analysis as a general term. So this is a supervised learning technique or unsupervised, even before talking about. Okay. So we don't know what's the text talking about or what document is talking about. We just look at the hidden feature. So there is no label. So basically unsupervised learning. So the technical term of latent semantic analysis, or LSA, has basically two different steps. The first step, we make a document term matrix, and the second one, the reduction of dimensions. But let's talk about document term matrix. Look at these 4 sample sentences. The quick brown fox, the slow brown dog, the quick red fox, the lazy yellow fox. By the way, I adopted so many of these documents from Databricks courses. So you can go to databricks.com and you can get some very good courses. I added some sections to that, but its majority is adapted from Databricks. Anyway, so here, how many variables I have in this small body? So again, in text mining or natural language processing, instead of saying data set, we set body. So how many variables I have in this body based on the matrix that you see? No, 4 documents, right? The documents are 4. 9. Yeah, you have 9 variables. So basically, in document term matrix, each word could be a variable or a feature. So instead of variable, you can say features to this. There's multiple names in the technical documents. Let me see if I'm recording. Yes, I'm recording. So what can do from here? One way is doing stemming or lemmatization. So it has different terms. Basically, we take a root of the words. One more steps that we can do, get rid of stop words. So look at there is almost in every sentence. It's not, doesn't bring that much of importance. So these are other steps that you can do. You can do feature selection. So because now we converted the textual document into numerical equivalent. So even you can do feature selection here. So again, the first part is just converted to numerical equivalent. Having 1 means that word is in the certain document. 0 means it doesn't. Any questions so far about the document term matrix? Even people over Zoom, if you have questions, you can use your microphone or just text me. So these 0 ones make right? 0 means that term is not in this document. 1 means there is. Okay. As you see, they are ordered alphabetically. And here we have 9 dimensions. So let's talk about singular value decomposition. Is it a technique that we use for focusing on the smaller variables or dimensions or components? So again, instead of variables, feature, components, these are like different names with the same meaning. You guys remember PCA? Yes. So again, if you forgot, please look at your previous courses, lectures, or also you can simply Google it. But let me just give you a simple explanation. So look at this shape. It has 3 dimensions or 3 variables. So, but as you see, the variation of the location, so each point or each observation has a location. All of the variation is in X and Y. There is no variation in the Z, or almost no variations. It seems one of our dimensions is extra. So it doesn't hurt me if I just show you the 2 dimension. X, Y. I didn't lose any information, and I use simple, smaller number of dimensions. Again, this is human eyes. For us, up to 3 dimensions is easy to imagine. So if it could be more than that, it's harder. So let's say, make it sometimes variations are not in X and Y and Z. They may not be vertical or horizontal. So let's look at here. I try to drop. Look at this plate. It cut my X and Y and Z in different locations. So this black dots mean just the intersection of the plate with those dimensions. And now look at my observations or points. So as you see, the variation of points location is over that plate, but you cannot simply say they are XY, YZ, or XZ, right? Still, it seems if I just use this dimension, now let me show it a better color. Maybe this color is better. Look at, I call it principal component 1, principal component 2. All of the variation is over that plate, which is not vertical in each dimension. So instead of using XY or XZ or any dimension to summarize variation of location, I just turned my plate PC1, PC2, So I show all of the variation in the locations with just two new dimensions. They are not either x and y or z. So this is the goal of principal component analysis. So you reduce number of dimensions, and also you don't want to lose information. You want to show all of the variations in the locations. So when you work with the textual documents, instead of 2-dimensional, 3-dimensional, you might have like 100 variables, which is very hard to imagine. But the goal is we use a less amount of variables and try to just transfer same information. Any question about principal component analysis? If it doesn't make sense, it's very hard, please just Google it or look at your previous courses and see the documentation. But the general goal, instead of using several dimensions, we use less amount of dimensions and try not to lose any information.
How does more dimensions improve accuracy?
Actually, when you have too many dimensions, sometimes you overtrain. So you cannot.
Overfitting.
Excellent. So when you overtrain, you end up having overfitting, which maybe you have a very good train set prediction, but you cannot generalize in the test set. And sometimes, even when you have too many variables, you don't get really good results because there's a mathematics behind of that. You're stuck in the local minimum or local maximum. Sometimes it gets very hard to find actually good result. Even in some cases, your train result is not very well. So in here, instead of saying PCA, we say singular value decomposition or SVD. As you see similar here, all of the variation in the points location is almost in this plate. There is something more than that, but most of the variation in 2 dimensions of a plate, this colorful plate. So instead of using X, Y, Z, we just use principal component 1 and 2 and show the location of the points. So same here, when we make document term matrix, you have 2 ways. One way using feature selection. By the way, you might already get rid of stop words, and already you might get the stem of the words. So these are something that you do in the preparation. But after having the matrix, maybe you have a better matrix that you don't have any day here because day is not useful. After this matrix, you have several approaches. One way feature selection, another one singular value decomposition or SVD. So we use basically use scikit-learn here, but as I said, it's not completely adopted in PySpark. Sooner or later, I assume most of its functionality would be available, but at least for SVD, you can easily use it in PySpark too. Let's look at this example. So we make a body of sentences. So our data set has 4 observations. The quick brown fox, the slow brown dog, the quick red dog, the lazy yellow fox. You might remember in the previous class we talked about count vectorizer. So for making back of the words. So we import count vectorizer from scikit-learn features. Basically make an empty object and fit over our body of words. As you see now, each sentence converted to a numerical equivalent. Again, this is just for simple presentation. Before that, you can get rid of stop words, and also before making matrix, you can get rid of. You can make the stem of the words. So here I'm using SVD. I'm importing truncated SVD from scikit-learn decomposition, As you see, I said number of components 2, but this is arbitrary name. I'm not sure 2 is good or not. So in your project, maybe you put 2, 3, 4. See which one gives a better result. So there is no guarantee that 2 is the best. Here for education purposes, we just use 2. I fit over the bag of words. Again, bag of words is just a matrix of the words that I have. And let's just print it. So as you see, the type of this transformed data frame is NumPy. And this is what you see. So instead of having 9 variables, we have 2 decomposed variables. Then I just converting this one to a NumPy, sorry, to a Panda data frame. Again, you might see so many conversions in PySpark or in general in Python, because some functions are just applicable over some certain format. So basically, whenever we do any format change, there's no mathematical behind of that, because some functions just work with some certain formats. It's how they code their function. So I make 2 columns of topic 1 and topic 2. These are my decomposed new variables. And also I put the body next to that. So I want to see what happened. So now instead of 9 variables, I just have 2 variables with the name of arbitrary name of topic 1 and 2. And just look at those 2 new variables. Tell me if you can see any pattern. For example, sentence 1 and 4 is about fox. Sentence 2 and 3 are about dog.
For the first three, it's like minimum and maximum, and maximum and last one.
You're talking actually good point.
But I don't understand why it's not the last one.
I mean, we just try to find a pattern. I mean, if you look at topic 2, for dog, both of them are negative and close. For fox are positive. It seems maybe topic 2 has the information about the animal type. Maybe if you look at here, this one variable has information of dog column and fox column, because you can use it for differentiating animal types. Maybe topic 1 is about something else, because for both of dog and fox sentences, they're positive and not very different from each other. So these 2 actually byproducts of latent semantic analysis, or LSA. At the end, you can have a dictionary and also then code the matrix. For the dictionary, we can use get features name method, and you can get your dictionary as a list. And for getting the matrix, you can use components underline, and you can get your matrix of the new basically terms. For example, let's say after this step, you want to you have a classification problem and you want to predict some certain. Let's say it was a tweet. So instead, how many words has it? I think it's 140, or they wanted to change it.
Sorry.
How many words or characters you can put in a tweet? 280. So they raise it to 280.
Yeah, they raised it from 140.
So basically, you could have 280 variables for predicting if a tweet is about election or about like something else, or a political tweet or regular tweet. So instead of using 240 variables, you can just do SVD and make like 2 new components, 3, 4. And after that, you can do prediction. So you can make a label. So first, maybe you download 1,000 tweets and label them as a political or regular. So you have a label column. Then the rest of the tweet, instead of 80 words, you have just maybe 4 columns or 5 SVDs, and you can do for prediction. Or maybe you can basically do several combinations. Maybe you change 240 words to just 10, and after that you can like do a feature selection on top of that. So you can just play different ways. Looking at this sample, let me see if I can see any pattern. Dog and fox for topic 1, they are very close. As you 0.33, 0.32. But for topic 2, dog is very, very negative. Fox, bless you. Fox is positive. Again, topic 2, it seems for differentiating the animal types. Or same for lazy and quick. For lazy is 0.43, for lazy is -14. By the way, there is very important in topic 1. It seems topic 1 is not really good variable because the most important variable is the THE. Anyway, these are different ways that we can play with that. So, by the way, we look at the absolute value. If the value of topic or new variable is close to 0, means that variable or component is not very significant. If it's very different from 0, either positive or negative, it means that could be a very significant variable. For example, topic 2 is very negative for fox, is very positive for dog. So it just means that's a contributing variable. So it's the reason I'm with the NumPy apps, I get the absolute value of the topic 1 and 2, put it in new columns of apps underline topic 1 and 2, then just sort them based on their value. So ascending equal false means it's descending order. So again, there is very important topic 1. So I just can say there's some issues here. For topic 2, if you order them, as you see, it's very important for fox and dog, I mean, in terms of absolute value. Any questions so far? So if there is no question, I give you a couple of minutes to play with the codes, then I go to the next part. You can just play with the codes, look at the different format that you have, then we go over more practical example. Yes?
So what is the value really means? Does that mean the importance of the features?
Actually, we are looking at the components or features of topic 1 and 2. We just try to find a pattern between the values that we have. So for example, we see topic 2 is very high for animal type. For both dog and fox, has a very high value. It just, it seems that topic 2 is taking the information of the animal type. It's the only thing. I mean, we just try to find some association between values that we have. Okay, so now let's go over a more practical example. We import some documents related to 2 books. The book names of change of the light brigade and Raven. So Raven is a poem book. And we want to just apply LSA, latent semantic analysis, over the document. So we import the document and just let's look at this. Here, just look at this blog. I'm showing you how to install a package in the Spark environment, more specifically Databricks. Just put this sign, then sh, then it's similar to a command, Python command prompt, oh sorry, Windows command prompt. Pip install, upgrade pip, and just downloading your package. Because NLTK is not a default package in Databricks. Most likely if you do AWS, it's not a default one over there too. But other packages are already installed in database, such as Pandas, NumPy. You don't have to install it. As it took, I think if you want to run the remainder of this notebook, you should already install in your instance. Anytime you make a new cluster instance, you should install the packages that are not available. So for example, if you delete this cluster, I have a class cluster here. So if I delete this one, next time that I want to use it, I should install the packages. If you use the paid version of this kind of cloud services, usually, I mean, you can keep your instance and you don't have to install it again. Again, NLTK is not completely available so far in PySpark. Most of the functions are available, but hopefully later soon you have all of the capability of NLTK. So from NLTK stem porter, I import everything and look at the porter stemmer. From that, I use the stem function, and I just put a sample to incomplete sentence of charge the guns, he's saying. So as you see, it changed to a lowercase, and instead of saying, we have say. This is one step above the previous approach, which we didn't do a stemming. By the way, this function is not perfect, especially if the past tense, it doesn't convert to the root. So you need to do something extra on top of that. If you need for project, just let me know. So I share some codes with you. So you need to make a for loop, just search, and whenever it's like past sentence, change it to the root. So this function is actually somehow good, but it's not good for the past tense words. So also I'm making a UDF. Again, UDF stands for user-defined functions that we had in the previous class. As you see, over within that function, I'm using lambda function. Again, lambdas are just a small type of function. Making some quick short functions. I'm just saying that, as you see next, the first one is what I want to apply. I want to do a stemming. And the format here is empty. So anything comes is fine. So I can do as integer, as or array. So I can change the format here, but here I'm fine. Anyway, so over body df, which was the data frame that I imported my CSV file, I make a new column of vector stem, which is made over running a stemmer UDF, which do a stemming of my sentence column. When I display, so as you see, I have a sentence column, title of the book, and the stemming result.
That's one thing that it's giving an error. Python exception giving error. Stemmer is not defined.
Stemmer is not defined?
Yeah.
Here?
Yeah. I'm not sure why. Maybe it should be, yeah, it should change it today.
Okay, so let me delete this cluster and run it again. So all of you got the error? Okay, maybe, I mean, let me see what I did. Maybe I deleted one line. So if it's happened, I check it again, because if I delete it, it takes a while to just get to this point. I updated, probably I didn't import something. So I update the Jupyter Notebook, and also at the end of the video, this video, I added like 2-3 minutes explaining it. Probably something, because I run it several times, maybe I just randomly did some sections. So I didn't import something here, I guess. So did you install NLTK here?
Yeah.
But okay, you got there. Okay. Anyway, sorry. So let me check it after your class. So again, I've converted to pandas because, I mean, for some functions, it's easier to work with the pandas. And also, I'm copying vector stemmed. I'm copying vector stemmed, which is the stemming column over the previous one. So I update the sentence column with the new value, and I just get top. I just randomly picked 5, and as you can see them here. So we have 5 stemmed documents, which all of them in lowercase, and we had some stems. Okay, so again, let me just go a little faster because it's similar to previous one. We do counter vectorizer. I'm just saying that it should be at least in one document, which makes sense. Otherwise, having a bag of words doesn't make sense. And also, I want to get rid of stop word, English stop words. I fit this object over my data, and my bag of words is basically all of those sentences minus stop words. Also, as you see here, I'm making new data frame with these 2 new documents. Here. So here I use SVD. Basically, instead of having several columns of words, I have 2 columns. Again, doesn't mean 2 is the best one. So if in your project, maybe you do 2 columns, 4 columns, or more than that, and see which one gives you the best result. Then I transfer it. So now instead of having several columns, I just have 2 columns that summarizes all of previous columns. So I make a new data frame with these 2 new SVDs or new components. And I also add a sentence column. So the sentence, which is a document, equivalent to new 2 variables. And also I add a new column of is poem. I said whenever it's equal to Raven, make it true. There is no reason, just later I want to use it for visualization. So true false set doesn't make any sense. It just means if it's true, means that document comes from the Raven book. If it's false, from the other book, deprecate something. So is the reason I want to do visualization different. I draw different data points. First, I want to draw everything is equal true, which means I draw the Raven observation. Then I draw everything is false, which is the other one. And since I just have 2 new components or new variables, I can use 2 dimensions for drawing. So if it was like, if my component was 3, 4, it was much more challenging to draw it in 2 dimensions. Here we can just, again, with the get features names, we can get our data dictionary, which I showed the top 10. This is my matrix. As you see, my columns are just dictionary order. And in the rows, I have the value in 2 dimensions. So what I did, I just said do transpose. So instead of having values in the, words in the column, I just put these 2 dimensions, and I just said, instead of 0, 1, put the topic 1 and 2. So it just turn this way. Also, I made a new column of terms. Instead of putting the dictionary order here, 0, 1, 2, 3, 4, I just have the word names. For topic 1, look at the values. The highest value of topic 1 is about door, chamber, tapping, visitor. It just makes some pattern there. So for topic 2, profit, nevermore, raven, think, evil, kind of a little association. So again, I take the absolute values. So let's look at the highest absolute values for topic 1, door, chamber, and same for topic 2, bird, profit, nevermore, raven, think, devil, evil. Now let's plot the figures. Again, I add the is poem column because first I want to draw the raven, which that observations that equal true. Then I draw for the brigade book, so all of the observations that are false. So I'm doing a for loop over the unique value of is poem, which is either true or false. So first they pick the true ones. You got the topic 1 and topic 2. This my X and Y. Then if it's true, because the for loop variable is val, draw blue, other was draw red, and the label is the raven for the true. Otherwise, charge of the light brigade. And topic 1 and 2, my X and Y, the color of the point is basically comes from here. Alpha means how dark or light is your points, and labels is just either these two book name. I put the axis name and the line width. And also we have a legend. So when I display it, as you see, it seems most of the points overlap with each other, except for here. Look at my mouse, and here you don't see any red ones. It seems these two new components doesn't differentiate between these two blocks, because almost with these two new components, most of them show as a similar topic. So what can you do from now? Maybe you could go back, change the dimensions, or in the next one, instead of using simple back of the words, I do TF-IDF. So if you forget to look at the previous session, in TF-IDF, we give some importance to some observations based on frequency of in a document or whole of a body. So let me skim through that. So similar to previous class, we import TF-IDF vectorizer and transform our bag of the words, our document. So then on top of using TF-IDF for bag of the words, we apply SVD. So now we try to summarize in two documents. Now let's look at the, again, if it's the Raven book, which is a poem book, I put true value, otherwise false. This is my dictionary. Now look at the absolute value. So let's look at the absolute value, highest value of for the topic 1. As you know, they are different. We had visitor, we had like tapping, now they are not here. For absolute topic 2, as you see, we don't have any profit, we don't have any evil, devil. So the basically the new topics that we just created gives more different values to the words that we have. It's because we use something different. Now, instead of simply drawing the observation in new dimensions, we also use TF-IDF before using SVD, before making new components. Now let's plot it. First, I do just simple plot with the previous data. Again, it seems the new component doesn't differentiate between the box. All of the points are overlapped. So it's here we almost see just blue dots. We don't see any red dots. With TF-IDF, look at here. Almost all of the Raven book are over our topic 1 or X variable. And second topic, it just shows most of the charge of the light brigade. By the way, you see just 1 or 2 points doesn't mean just 2 box. If you look at the data, there are several charges of the light brigade and several of the Raven. But since they are overlapped to each other, you just, for example, for the charge of the light brigade, you just have 2 observations. Maybe some of the overlap 0 here. But as you see now, these new components very well differentiate between these 2 types of box. It seems they are working well. Maybe later, if it's a prediction problem, I can use these 2 variables for predicting which kind of box. So probably they can predict very well because they easily differentiate between these 2 categories. Or if it's unsupervised learning, it seems these 2 variables shows a very good variations of your observations. So this experiment just showed the importance of TF-IDF. As you see, I didn't change my number of components. I just used TF-IDF and end up having a better representation of my data. And sorry for the error. I assume I randomly deleted import function. Let me just delete the cluster after your class and I just update the Jupyter notebook. And you have any questions later, we can talk and resolve it. Okay, any questions? So again, it's not a complete project because our time is limited in the class. You just understand, you just keep in mind basically that for the natural language processing, you have one extra step, how to convert your textual data to the numerical equivalent. And as you see, similar to numerical values, we can have feature selection, we can use principal component analysis, and sometimes like using some techniques like TF-IDF are really helpful, which in this case, easily differentiate between 2 categories of data. After this, maybe what you can do, okay, let me just teach in the next session. I want to give you an assignment, but I think let's just study the next session so you can have a more complicated assignment. But for your practice, now you have 2 variables. As you see here, easily differentiate between these 2 categories. Try to do a prediction. Try to predict, because you also have the label. Look at here. So many data. So you have title. You can assume title is your dependent variable. Your new values, topic 1 and topic 2. Okay, let's make an assignment. By the way, I appreciate you give some good comments. I mean, some of your midterm comments is about assignment. So just do assignment, and I posted today. Try to predict the title with 2 different input. one input using TF-IDF, another one without TF-IDF, and show me which one gives a better prediction. It could be interesting. Sometimes even I assume the TF-IDF gives you a better result, but who knows? I mean, you should try. So most likely using TF-IDF as your input variables, you could get a better prediction. And maybe you can even play with the number of components. So instead of 2, 3, because there is no mathematic behind of how many components is best. You just use 2 as an arbitrary number, and we got really good results. So any question about your assignment? I mean, the only thing I expect from you, two different prediction. Basically, one without TF-IDF, and the one with TF-IDF. So basically, this is like basic notebook that you have. On top of this notebook, you have a prediction section. So you add a prediction, you have a test set, train set, and you can divide in any like 20%, 80%, or 30, 70%. It's arbitrary. So you predict and show me that which one gives a better result. I mean, it could happen that with TF-IDF you get a worse result. That's fine. I mean, I just need you guys to do practice and see what happens. Most likely, with TF-IDF, you have a better prediction. So, is there anyone in this class or over Zoom that your final project is about text mining? I don't know. But even if it was, there's no big issue. You just need to add extra blocks to convert your text to a numerical equivalent, and the remaining is the same. Some company, if you end up working in the business as a business analyst, sometimes you work with the customer review a lot. So you want to see what your customer talking about your products. This is really helpful. It looks challenging at the beginning, but it's nothing just converting textual document to good numerical equivalent. Sometimes you convert, but for example, every time people just did back of the words for prediction. The prediction was not good. Then they think of, okay, let's get rid of stopwords. They had some improvement. They had feature selection, principal components. So they tried so many algorithms, and every day they get some improvement. So even if you work with the image data, which we don't have time to cover in this course, we had something similar. We had some image processing in your business and analytical programming, but again, just you need to add some extra block for converting the image information to equivalent numerical values, and the remaining is same. For image processing, usually deep learning gives a better result, not always, but for prediction, maybe if you use deep learning, you can get a better result. So any question from people over Zoom? By the way, I will do this through your groups. I want to later to see what your issues about your project or any comments that you have for the class. I also look at your comments for midterm because I'm not sure if I have any classes with you guys more. So I just want to end up this class in the best way that you expect. So hopefully you get good insights. So questions from people over Zoom? Now you have more classes, but I'm not sure if you have any more classes with me. So any question from people in this class? No? Okay. So if there is no question, that's it. Thank you for today. So I checked this Jupyter Notebook for the error that you mentioned, and also I post the assignment for today. Okay, thank you, and have a good rest of the day. Hello everyone, I hope you are doing well and healthy. Regarding the Jupyter Notebook that I taught in the class, it was a typo. for the function that I used when I wanted to do a stemming. Let me just go over that. So in here, I do a stemming for a sample document. As you see, I used port stemmer as a function, and on top of that, I used stem method. But here, it was a typo, so instead of port stemmer, I used something else. I already uploaded the right notebook in your model. Please download this one, and now you can write without any error. Regarding to your assignment, look at the data that we brought in. It's some sentence, or which we call it documents, and we have a title. So the title either is charge of the brigade or the raven. So it's like your dependent variable has two categories. So it's like a predicting a dependent variable with two categories, similar to other prediction that you have. But our independent variables in terms of sentences or documents, what we did in this notebook, first we made bag of the words. Then it was too many variables. What we did, we used singular value decomposition, or SVDs, and had two independent variables instead, topic 1 and topic 2. And for your assignment, just keep working on this project. So as you see, I just used two components or two variables because I wanted to draw a figure. And for figures on the 2 dimensions, I cannot use so many components. So because these components could be associated to a dimension. So you can increase your components from 2 here to 3, 4, or more than that, and see what result we can get. So basically, you can keep working on this notebook, add your blocks. So use this notebook as a basic and add several components or blocks after that. So for example, you can do prediction and report the accuracy and AUC. Also, do in the second way. Maybe one way you just use bag of the words as your independent variables, but it's too many. So you can do feature selection and limit them. Or maybe one SVD alone, one SVD with TF-IDF. Or the second approach could be bag of the words plus feature selection. Let me use my board and explain over the board so it makes more sense. Okay, this is my board. So what was the problem? We had sentences and title. It was charge of the light brigades, or the raven. So 2 categories. And you have some sentences or documents. So what we did actually in this Jupyter notebook, or last session, we took this raw data So we cannot do that much of thing with raw data. We need to convert to numerical equivalent. So first we did bag of the words. Then we did SVD with two components, You can increase the number of components to 3, 4, or whatever you want because you don't have to do visualization. Then you can do prediction. You predict your title as dependent variable and see the results. The second approach could be you do raw data, convert to equivalent, numerical equivalent of bag of the words, then feature selection, then you predict. As you see in these two approaches, almost every steps are same except for feature reduction. Because sometimes when you have too many features, you do overfitting, or even you don't get a good prediction because your algorithm couldn't pick the right number of right features. There's too many features. So if bag of the words and feature selection is more difficult, I recommend to try that. So the second approach could be raw data, bag of the words, using TF-IDF plus SVD, then predict. So you can have one SVD without TF-IDF, one with TF-IDF, and another one just feature selection. And you can just compare results and see which one gives you the best possible outcome. So use the Jupyter notebook that I shared as your base and just build on top of it. You have 1 week for submitting the assignment, and just in case you have any questions, please reach me during my office hours, or just if my office hours don't work for you, just shoot me an email and we can have some discussions. Anyway, again, sorry for the typo that we had in Jupyter notebook. Now it's fixed. Please work on it and submit this assignment. Thank you very much and have a great rest of the day.